Hey there, welcome to this explainer. I am absolutely thrilled you're here today. Look, if you're a junior developer or a complete beginner looking to build some really solid professional coding habits right from the start, you are in the perfect place. Just think of me as your friendly mentor today. We're going to tackle one of the absolute most vital concepts in programming, which is keeping your code clean, manageable, and professional. Okay, grab a coffee and let's just dive right into this. So picture this. You're working on your very first big project, you're solving a real problem, and naturally, you just keep adding to it. Soon enough, you're staring at a single file with 1,000 lines of code. What happens next? Well, stress happens. There's actually a famous joke among developers. If debugging is the process of removing bugs, then coding must be the process of adding them. When you dump absolutely everything into one massive file, fixing a single bug usually creates two more. After a few weeks, you look back at that script and think, man, when I wrote this, only God and I understood it. And now? Now only God knows. Finding and fixing errors in that environment is literally a nightmare. And this comparison right here perfectly illustrates our core issue. On one hand, we've got that messy single file. Every variable, every piece of database logic, every single step is just crammed into one place. It is totally impossible to navigate. And worse, only one person can work on it at a time without stepping all over someone else's toes. But on the other hand, we have clean, separated files. By dividing our project up by features, isolating that code makes tracking and fixing bugs infinitely less stressful, especially when you're still learning. Plus, it means multiple people can jump in and collaborate at the exact same time. All right, moving on to Section 1, the wardrobe and the spice, real-world metaphors for coding. Let's actually step away from the keyboard for just a second and look at some everyday examples to make this click. Think about organizing your wardrobe or your closet. Imagine just taking your tops, your jeans, your pajamas, and throwing them all into one giant, chaotic pile on the floor. Now try yanking a shirt from the very bottom. What happens? The whole pile collapses, right? Everything gets completely messed up. Well, that's exactly what happens when you write all your code in one file. You change a tiny line at the bottom, and suddenly you ruin the logic at the top. The fix? You just separate your items. Tops go on one shelf, jeans go on another. Suddenly, picking out an outfit, or in our case, finding a bug, is totally effortless. Now, what's really cool is how this connects to another massive benefit, code reusability. Let's head to the kitchen. Imagine you absolutely love putting roasted cumin powder on your snacks. You wouldn't roast and grind cumin seeds from scratch every single time you grab a snack, right? No way. You do the hard work once, grind the powder, and store it in a nice little container. Then you just sprinkle it wherever you need it all week long. In programming, it's the exact same vibe. If we write a complex, difficult piece of logic, we don't want to rewrite it every time. We want to store it in its own container and reuse it anywhere we want. Which brings us perfectly to Section 2. Enter the Python module. This is the ultimate solution to our messy code problem. So let's completely demystify this word module. It sounds super fancy and technical, right? Actually, scratch that. It's not fancy at all. A module is simply a file that contains Python code. That is literally it. Any file with a .py extension that holds your variables, statements, functions, or classes is acting as a module. So instead of writing one giant script, you break your project down into smaller logical parts, creating separate module files for each part. Oh, and a great pro habit to start early? Make sure to document your module code using comments. It guarantees absolute clarity for anyone on your team reading it later. Let's ground this in a real scenario. Say you and a friend are building a quiz game. If you dump 50 questions, all the answers, and the game rules into one file, it's going to be unreadable. But what if you create a nice folder structure? You put your questions in one module called quiz_database.py and the rules in another file called main.py. Separating that static data from the active logic prevents accidental changes to your main code. And the best part? You can be working on the game rules in main.py while your friend is adding new questions to the database file at the exact same time. Teamwork just becomes completely seamless. All right, Section 3, built-in versus custom modules. Basically, tools from Python versus the tools you build yourself. Because you definitely don't always have to start from scratch. We generally deal with two main flavors here, built-in modules and custom modules. Built-in are the tools Python just hands you out of the box for common tasks. Like, do you need to do some complex math or generate a random number? Don't write that yourself. Python already did it for you with the math and random modules. Custom modules, on the flip side, are the ones you create for your unique project. like that quiz database we just talked about, or maybe a custom calc file we build to hold specific functions we want to reuse across different programs. Oh, and I've got a super cool pro tip for you here. If you ever want to explore the massive library of built-in tools that Python offers, just open up Python and type help, modules. It prints out this huge list of every built-in module available on your system. It's such a fantastic way to discover what Python can do for you without you having to write a single line of logic. Moving on to section 4, how to import modules. This is about bringing that external code into your main file. So we have these separate modules sitting in our folder. How do we actually make them talk to each other? Well, we do this using the import keyword. If you type import math at the very top of your main file, you're basically telling Python, hey, go grab the math module and give me access to everything inside it. But to actually use it, you have to use the module's name as a prefix. So if you want the mathematical constant e, you have to type math.e. Now, this is super organized, but honestly, having to type math. Every single time can get a little repetitive. So if typing that prefix gets annoying, or if you only need one specific tool from a massive file, you can use the from keyword instead. For example, from calc import add. This explicitly reaches in and pulls out just the add function from your custom module. Now, you don't need a prefix at all. You can just type add directly in your code. By only importing exactly what you need, you actually save memory compared to importing the entire library, keeping your program super lightweight and efficient. But what if your module name is just way too long? Say you created a custom module named calculator. Typing calculator.add 100 times a day is gonna get old fast. Well, you can use an alias. By typing import calculator as C, you are literally just renaming that module inside your current file. From then on, you just type c.add. It saves so many keystrokes and keeps your code looking incredibly clean and readable. Section 5. Preventing variable name conflicts. Keeping your data isolated and safe. Okay, as your mentor, I really have to warn you about a very common trap that almost every junior developer falls into when they start splitting up their files. Imagine this scenario. Let's say in your main file, you create a variable called a, and you set it to 4. Simple enough. But you also imported a custom module, and inside that module, one of your teammates defined their own variable, also named a, and set it to 10. If you just tell Python to print a, what happens? Does it pick the 4? Does it pick the 10? This is called a name conflict, and it causes massive confusion and some really frustrating bugs. And this is exactly why using module prefixes is an absolute lifesaver. If you import the module directly, Python beautifully isolates those variables. To get the 10, you explicitly write mymodule.a. To get the 4, you just write a. Using the module prefix completely resolves the conflict. It ensures Python and your teammates know exactly which piece of data you're talking about. It keeps everything isolated, safe, and perfectly clear. All right, section 6, why modular code wins. Adopting the professional developer's mindset. As we wrap up our session today, I really want you to internalize why shifting away from that single messy file is the true hallmark of a pro. So let's sum it up with the top 3 reasons splitting big projects helps your productivity. First, easy maintenance and faster debugging. When you isolate code, tracking down a bug means checking a tiny 50-line file instead of a 1,000-line monster. You can even thoroughly test a single module all by itself before ever plugging it into your main project. Second, unmatched code reusability. Just like our cumin powder, you write a handy script once and you reuse it in every future project without rewriting a thing. And third, seamless team collaboration. By assigning different files to different people, your team divides the work easily, and tracking those changes across multiple files using version control like Git becomes an absolute breeze. Breaking your projects into logical modules isn't just about making the code function, it's about making your code professional, scalable, and genuinely fun to read. Modularizing your code makes long-term maintenance of the project so much simpler for you and everyone else. So my final question to you is this. Now that your code is clean, manageable, and organized beautifully on its proper shelves, what are you and your team going to build next? Thank you so much for joining me for this explainer. Keep your code clean, and I will see you next time.